So this is a photo that we have kind of plastered in front of our refrigerator door. It's a picture of me when I was about just 5 years old. And now I usually don't like looking at photos of myself, especially old photos of myself. But I do, however, tolerate this one because from time to time it allows me to zone out and think. Think about my past and where I came from, the events that led me to where I am today, and the future, where I'm headed, where I might be going. But more importantly, it allows me to think about the lives of other people as well. And as I kind of compare the stories of friends, family, and even the cashiers I meet at the grocery store, I start going down this kind of rabbit hole that leads to one of my ultimate questions, which is what makes us human? Now, personally, I don't think we'll ever have a solid answer to this question. It's a mystery that will definitely have us thinking for a while. However, with the things that we have learned throughout the semester in our biological anthropology class, I think we can have a better understanding of what the answer to this question might look like. So, hi, my name is Quan, and today I'll be talking about human evolution and the story of who we are as a species. So, before we talk about our family lineage, I kind of want to talk about what separates us from other organisms. What makes us unique compared to other chimpanzees or gorillas or orangutans? And so what we found out was it's not our brain size or our use of tools that makes us unique, because we have discovered that in other primates as well. But in fact, it's our ability and our dependence on our 2 feet. More specifically, it's our use and trait of bipedalism. So, what is bipedalism? Well, according to Solari and Argewal, authors of Laboratory Manual and Workbook for Biological Anthropology, it's a form of two-footed locomotion where movement occurs primarily through the use of hind limbs. So there are three different types of bipedalism that we have discovered. And so the first one is occasional bipedalism, which is practiced sometimes or occasionally, and it relies on a different form of locomotion as a primary means of movement, but they can resort to bipedalism under certain circumstances. Habitual bipedalism is a bipedal locomotion that is practiced regularly or habitually. Habitual bipeds may also rely on a different form of locomotion, but they use bipedalism and other locomotion strategy more equally than occasional bipeds do. And last but not least, obligate bipedalism is a bipedal locomotion that is practiced all the time. So obligate bipeds are obliged to move around bipedally. And unlike occasional or habitual bipeds, obligate bipeds have no other realistic locomotor options. So for organisms who practice bipedalism, there are some adaptations that come along with it. So according to Daniel Schmidt, the author of Insights into the Evolution of Human Bipedalism from Experiments and Studies of Humans and Other Primates, one of the changes are the position of our skulls. The four-eared magnum is in a biped is positioned more anteriorly towards the front of the cranium and inferiorly on the underside of the cranium. This position allows the head to be centered over the upright vertebral column. So the position of the head also allows a more relaxed normal head position in a biped, with the eyes facing forward and its neck muscles not being overworked to orient the head correctly. So another adaptation that we can find among bipeds are curved spines. Our spines are, compared to other primates, are more S-shaped and curved in the thoracic and lumbar region. So according to a study published by the American Association of Anatomy, although it's dangerous, it provides a good compromise between mobility and stability. And so the reason why it's so dangerous is because it's so fragile. It's a lot of pressure on just a very tiny amount of space. And compare in nature, we can see that most organisms have a curved spine, which is a lot more stable, a lot more safer. However, with humans, because of our placement of our skulls and bipeds in general, we have a more curved, fragile spine. And going down the body, another adaptation that we can see is changes in our pelvis. Our pelvis is slightly more bowl-shaped, and it's largely the result of differences in the two ilia. So in a biped, the ilia are short and broad and positioned more laterally in the pelvis. The shape is related to adaptations in the leg muscle of bipeds, and it provides stability in standing, walking, and running. And it also reduces the muscular work to maintain equilibrium. We do use a lot of our leg muscles. So according to a study published by Evolution, Education and Outreach, the largest body parts of primates were parts that they use most often for their form of locomotion. And so that has resulted in large femurs, tibias, and fibulas, which make up the length of the leg. And in addition to that, we have also formed something called a valgus knee, which is the knees in a biped angled inward to give it a knock-kneed appearance. The angle formed by this long axis of the femur shaft and the horizontal knee provides an angle greater than 90 degrees, which is significantly greater in humans than in most apes. And this helps provide stability in walking and running, especially when only one foot is on the ground during locomotion. And last but not least, we have some unique sets of feet as well. So according to J.R. Napier, who is the director of the Unit of Primate Biology at the University of London, we also have a longitudinal foot arch, which is a distinctive arc that runs from the front to the back of the bottom surface of the feet. And it gives an increased leverage as the body pushes forward and also serves as a shock absorber when the feet makes contact with the ground during walking and running. And we also have a large hallux, or a opposable big toe, that reflects the function of the foot, which is solely to support the body during walking and running in humans. And it has a dual function, which is walking and grasping or manipulating objects. But as humans, we have lost our ability to manipulate objects with our toes. And to kind of summarize it all up, here is a chart from the textbook Essentials of Biological Anthropology by Clark Spencer Larson, which kind of, I think, was a very nice diagram to kind of point out the differences between primates and hominins. So you guys are probably dying to know, why bipedalism? What about it made it such a favorable trait among hominids? So one of the more popular theories is the savanna hypothesis. So according to an research article published by the Scientific Reports, the savanna hypothesis argues that bipedalism was a favorable adaptation in an environment that facilitated life in open grasslands with interspersed pockets of trees. Another hypothesis is the patchy forest hypothesis, which also ties the evolution of bipedalism to environmental changes as well. However, it also argues that bipedalism is more energy efficient than walking around on 4 limbs instead of 2. Another explanation based on environmental changes is the thermal regulation hypothesis. So this model argues that bipedalism was favored because it helped our early ancestors manage their body temperatures and stay cool during the heat of day. So another hypothesis is a provisionary hypothesis. And it argues that bipedalism evolved in early humans that were monogamous, specifically to allow male human fathers to carry food and resources to their female partners. And in one final hypothesis is a post-stral feeding hypothesis, which is also based on the feeding benefits associated with bipeds, although it doesn't assume any particular social relationships. So now that we have established why bipedalism was more of a favored trait, we can now get into the bread and butter of what this presentation is, which is our family lineage, which starts with the pre-Australopiths. So the pre-Australopiths were the first sets of fossils that we have found to be not only the earliest, but the ones that have been shown to first practice bipedalism as well. So the first fossil record that we have, and is our earliest fossil record that we have of the pre-Australopiths, is in a species called Sahelanthropus chadensis, which is dated back to be 7 to 6 million years ago and was found in the west of the Great Rift Valley in East Africa. So the skull of chadensis is very robust, and it has a chimp-sized brain and pronounced ape-like muscle attachments. And so what we have also found was that the foramen magnum is anteriorly oriented, which suggests an upright and bipedal hominin. And so, like many other early hominins, it has a produced brow range, and it has a small cranial capacity. And it was also shown to maybe be a forest dwelling organism as well. So the next pre-Australopith that we encounter is Ororiontugensis, which is dated back to be around 6 million years ago and was found in Kenya. So we have very few body parts of this species, but what we do have are partial humerus, femurs, and mandibles, and a distal thumb, and some teeth as well. And so the molars that we found were covered with a thick enamel like those of later hominins, but they were still small like our own, and they were laterally expanded as well. So next up we have on our timeline is Ardipithecus cadaver. So this species was dated back to be 5.4 million years ago, and it was found in the middle Awash region of the Afar Depression. And there are not a lot of fossils of this species, but what we do know is that their dental characteristics are more ape-like, and their toe bone suggests bipedal foot movement, involving the kind of off-toe motion that we have when we push off with our toes on one foot and we plant our other foot in a sort of swing phase. So the last of the pre-Australopithecus that we know of is the species called Ardipithecus ramidus. So it's dated to be around 4.4 million years ago, and like Ardipithecus cadaver, it is found in the East African Rift Zone in the middle of the Awash region. And so this species is particularly famous because of the discovery of a fossil named Ardi. And so Ardi was not only a near complete skeleton, but it was the first to show and give evidence of bipedalism in what we think of as apes. And so Ardi had many traits of both bipedalism and brachiation, which is forest dwelling, which is related to something more of organisms that swing among branches or climb. And so with Ardi, we learned that this may have been where we started to kind of go from primates to diverge into hominins who can walk on our two legs and kind of depend on our two legs to get around. And so at this point, the next portion of our family lineage goes into the Australopiths, or in this case, the gracile Australopiths. So the gracile Australopiths were a group of our ancestors that lived about 4 to 1 million years ago. And so all of these species were habitual bipeds with a mixture of bipedal and arboreal adaptations, and they varied in size and robusticity. And some species were smaller and more gracile, and others were larger and more robust. And as we can see, this has kind of led to different classifications and separation of the gracile and robust Australopiths. So the first earliest known Australopith, or gracile Australopithecus that we know of is Australopithecus anamensis. And so it's dated to be about around 4.2 million years ago, and it was found in Kenya. So not a lot much is known about this species because we don't have a lot of fossil record, but what we do know is that their teeth, jaws and teeth are very primitive, and they have been shown to have a high degree of sexual dimorphism. So next up on the list we have Australopithecus afarensis, which is found to be dated around 4.2 million years ago in the regions of Ethiopia, Tanzania, and Chad. And so two of the more famous fossils, Lucy, which is about 40% complete, which is making it one of the most complete fossilized skeletons that we have, and Salem, which is dubbed as the Dika baby or Lucy's child. Which has contributed to a lot of our understanding of what primate hominins and apes maybe kind of look like. And what we have found were they were not only they were habitual bipeds with both arboreal and bipedal characteristics, but it showed that they had prolonged juvenile dependency and brain growth. And for the first time ever, we were also able to see that they had bipedal hips and lower limbs. So next up on our evolutionary timeline, we have a species called Australopithecus africanus. And so these species was dated to be back to around 3.6 to 3.2 million years ago and was found in regions in all over South Africa. And so the most famous discovered fossil of this species, the Twang child, revealed a lot of stuff about our evolutionary timeline. And so what we discovered within this species was that it had a enlarged cerebral cortex in the frontal and partial regions, and including a Broca's area, which is involved with the production of language, present as well. So here we can see what might have been the beginning of how our complex thoughts developed and our culture developed as well, and language. And so next up we have Australopithecus gari, which is dated to be around 2 to 3 million years ago, and there aren't many remains, but and the only place they have been found in so far is Ethiopia. And so there are a lot of debate going on among researchers about whether this belongs in the Paranthropus, which is a more robust Australopithecus, or the gracile Australopithecus. And the reason for this is because the skull seems a little bit more robust and more bigger and elongated. But however, there has been evidence of butchered animal remains, so they might have possibly created tools as well. And so speaking of Paranthropus, the next part of our family lineage will be including the groups and species of various different types of Paranthropus. And so Paranthropus were noticeably different from other more gracile species that came before. They were more robust with larger dental facial and cranial features and larger back teeth. And so their size of reduced front teeth may have been allowed to enough space in the mouth for the larger back teeth. And along with enlarged chewing teeth, robust Australopiths had larger mandibles, which would have needed larger jaw muscles to move. And these jaw muscles were so large that they needed extra bone in form of a sagittal crest to attach to the top of their head. And so the first Paranthropus that we encounter is Australopithecus aethiopithecus. And so this specimen was dated back to be around 2.7 to 2.3 million years ago, and was found in regions in Ethiopia and Kenya. And so what was especially known about this is that it was very prognatic, in the sense that it had ape-like arms, a small brain, and robust craniofacial dental characteristics, and possibly longer, more human-like legs. And so next we have Australopithecus boisei, and their remains are dated back to be around 2.5 million years ago and has been found in Ethiopia, Kenya, and Tanzania. And so just like with the previous Australopithecus, there are some the same robust characteristics, but what is different about this Boisei is that it has the largest supraorbital torus out of all the Paranthropus, and this is suspected to be because of the environment they're living, where they had to have a lot of vegetation to eat and a lot of chewing involved. And so next up we have Australopithecus robustus, and their remains have been dated to be back around 2.3 million years ago and has been found in areas in South Africa. And so what's fascinating about this species is that they have the largest cranium capacity, 530, making them the largest that we have seen so far. And so evidence has been shown that they were capable of making and using tools, and so that's why we kind of associate tool making along and hominins with brain size. And so after Australopithecus robustus, we have finally Australopithecus sediba, which is dated to be around 2 million years ago, and was found in South Africa. And so what's unique about this one is it has both Australopith and Homo characteristics. And so there is a reorganization of the frontal cortex, which shows that they may have produced some sort of language. They have Homo-like tooth shape and growth pattern. They also have human-like aspect of the tibia, ankle, and foot, and possibly a unique form of bipedalism. But at the same time, they do have a Australopith-like growth trajectory of their teeth and jaws, and their head and neck. So many researchers do think that this is where we kind of start to diverge into our own lineage, our own family, our own species, which is a Homo genus. So in this section, we kind of explore the Homo genus, which is our closest species that we know of. And so some key traits that distinguish them from earlier species, such as Homo habilis, the earliest one that we have, is that later Homo species had a larger cranial capacities and more flatter faces and smaller teeth. Their postcrania were also similar to those of modern humans, and unlike relatives, these later Homo species were obligate bipeds. And they also had a wider geographical range than earlier species, as you will see. Fossils have been found pretty much all over the world. And they also had more complicated cultures and technologies than earlier species as well. So the first Homo species that we kind of encounter is Homo habilis, which is dated to be around 2.3 million years ago. And it was the first member of our own genus to live alongside by side with the robust Australopiths in eastern and southern Africa. And so the remains have been found in Ethiopia, Kenya, and South Africa. And so they possessed a high degree of sexual dimorphism and increased asymmetry in hemispheres of the brain, especially the enlarged Broca and Wernicke areas, which are areas associated with language development. So this is really where we start to see more complex thoughts, or quote-unquote complex thoughts, being formed biologically within the Homo genus. And so along with this, they have also been shown to, as far as we know, be the first ones to create their own technology, the Ohlone technology, which consisted of simple core tools and flakes, and it was a technique involved in the selection of a cobble, workable size rock, and the use of a hammerstone to remove the outer rough surfaces and to shape it into a core tool by the removal of flakes. So next up in the Homo's genus, we have Homo ergaster, which is dated to be around 1.8 million years ago and is found in Algeria, Morocco, Ethiopia, and Kenya, and South Africa. And so the most famous fossil of this species is a fossil called Turkana which is one of the few very complete skeletons that we have today. And so what is interesting about this skeleton is that it showed how human-like we were post-cranially. And so this, along with Homo habilis, has kind of painted a picture of when and where we started to develop more complex brains. And so next up we have Homo erectus, which is dated back to be around 1.8 million years ago. And so it's very similar to Homo ergaster. However, what is more unique about this is the places it was found. So this is really the first evidence of the species Homo that we have kind of expanding outside of Africa. So their remains were found in Java, China, India, and Turkey, near around Asia. And so, fun fact about this species, Franz Weidenreich, who discovered some of these fossils, had them shipped to the U.S. However, the material disappeared after unknowingly, and they have never been recovered since. So we have very limited, to say we still have some limited knowledge about this Homo species. So next up in our evolutionary journey, we have Homo antecessor, which is dated back to be around 1.2 million years ago and was found in Spain. And so this is really the first time we see evidence of the Homo genus in Europe, or West Europe as well. And so this species possessed a larger brain and a more modern skull and face compared to the other species. And it also had low foreheads and possessed an occipital bun as well. After antecessor, we have Homo heidelbergensis, which is dated back to around 600,000 years ago and was found in not only Africa but Asia and Europe as well. And that is significant because now we can see evidence of the Homo genus expanding way outside of Africa as well. And so from its fossil records, we can see that it has ramped up in brain size and the complexity of skull structure and its corresponding volt changes as well. And so after Homo heidelbergensis, we have Homo naledi, which is dated back to be around 236,000 years ago and 335,000 years ago. And so what's really significant about this one is it wasn't just one specimen that was found in multiple areas, but in fact many specimens found in one area in the Rising Star cave system in South Africa. And the area that was found and just the nature of what was found in that area has led us researchers to believe that it was in fact a burial area. And this is significant because really before the discovery of this fossil, it was believed that Homo neanderthalensis was first to practice burial techniques and symbolism. But however, this discovery of this species has shown us that the Homo genus has been practicing ritualistic behavior since as far as 335,000 years ago. And so we get to Homo neanderthalensis, which has been shown to be found to be around 300,000 years ago, and it was all over Western Europe. And so they were smart. They were able to create technology. They had art, symbolism, burial. They had a culture, really. And they were shown to interbreed with our own species, Homo sapiens, as well. And so, what is really mysterious about this is that we aren't really sure how they became extinct. Um, but with new research and evidence, it has we have come to see that maybe we interbred with them so much that they kind of became assimilated into our own population as well. And speaking of Homo sapiens, here we are in our place in our own family tree. And so we have heard about 200,000 years ago, and we have been shown to be all over the place. Our fossilized remains have been found in the New World, Europe, Asia, and Africa, and Australia. And so our brains were structured differently. It wasn't big or anything. It was just we had in some certain places, such as the Wernicke's area or the Broca's area, it was more larger than other previous Homo genius, and we had a lot of technology, we had culture, and we had a lot of symbolism, similar to Neanderthalensis. However, we were a lot more widespread than they were. So, in conclusion, our history is complex, to say the least. We don't have all the information, and the information that we do have is often very little. However, with what we do have, we can paint really a beautiful picture of what our lineage looks like and our past, where we came from, and the roots of our existence. And to me, I think there is nothing more fascinating and and beautiful at the same time. And so, thank you for listening. And here's my works cited. Thank you.